You might have heard of Devin, the first autonomous AI software engineer. Now, there is also an open source AI software engineer. This is from Princeton University. It's known as SWE-agent. This SWE-agent turns language models. It makes use of GPT-4 into software engineering agents that can fix bugs and issues in real GitHub repositories. So on the full SWE-bench, now what is this SWE-bench? So if you look at SWE-bench, it's a benchmark for evaluating a large language model on real-world software issues collected from GitHub. Given a code base and an issue, a language model is tasked with generating a patch that resolves the described problem. So on this benchmark, on the full benchmark, basically, on the full test over here, right, full test set, this particular agent achieves 12.29% of resolved issues. Okay, 12.29% of issues are resolved using this particular SWE agent. Whereas Devin had 13.84% resolved issues, but it was only on 25% of this full test set. Okay, so that is where this is supposed to be a state-of-art performance on the full test set. So this SWE agent can resolve and fix bugs and issues in real GitHub repositories. So they have a demo over here. They have a website basically, and they have a demo page also. So if you go to the demo page, let me reset it. Okay, so this is a particular issue which has been pulled up from GitHub, right? This is a particular issue in a particular library called pvlibpython. So here is the issue. Description is present. There is the code which is present, which is creating the error. Okay, so how does this SWE agent go about solving this? So you can click next step. It says to start addressing the issue, we should first try to replicate the bug. So copy that code and put it into another file called reproduce-bug.py. So first step is it creates this file. Okay, so it is able to create this file in the terminal. Right. Next is it will actually, it needs to copy this particular. It has an editor where it will copy this particular file. It will and it will paste the example code. Okay. So that is what it does over here. It passes the example code over here. And then if you go to the next step, it says that now this file has been updated. Now we have to run the file to see the script. So what is the command for that? It generates this command python reproduce-bug.py and then it actually runs it. When it runs it, it finds out that, based on the results, it finds out that the error has been produced. Okay. Now it finds that the error is coming from this pvlibtools.py file. So it will go there. It has to navigate to that. So it opens that particular file. Right. So it is actually open that particular file over here. And then it says that this function is not visible in the first 100 lines. Since the error didn't specify exactly where this thing, we will use the search file command to find within the tools.py. So again, this search file command is present, okay, to find this function in that file. So it finds that it is present over here. And then it takes turns and let's see how is it implemented, understand how it's implemented. It goes to that particular function, okay, in the code. And then it tries to, this function does this thing. The error occurs when the divide by 0 error happens when calculating this thing. This issue arises because the golden string algorithm requires a range upper lower to operate on. When both are equal, the range is 0. So that is where the bug comes from. So how to handle this is what is it tries to see, and then it tries to solve this issue. Okay. So in an iterative way, it makes of its internal tools like a search function. That's what they're saying over here. It has access to some internal tools like a specially built full directory string searching command. So it makes use of that. It has a special built-in viewer which can show 100 lines in each turn. Okay. It has a linter that runs when an edit command is issued to check for syntax. And if there is an empty output coming, then it returns a message saying that your command ran successfully and did not produce any output. So this is the idea over here. It makes use of its internal tools and making use of a language model as an agent. It tries to solve and fix issues in real GitHub repositories. So they're going to come up with a paper on April 10th. So I'm looking forward to the paper. In the meanwhile, you can check out their demo over here. You can check out their webpage. This is a short video on SWE-agent, which is an open source AI software engineering agent. And I hope more such AI software engineering agents come out in the open source, and maybe they are better than Devin or any other closed source AI agents. And this should help software engineers improve their productivity. If you like the video, please like, share, subscribe to the channel. See you in another video.